TW cable should not be used as a direct replacement for THHN cable, particularly in residential branch circuits. THHN, or thermoplastic high heat resistant nylon coated, is a specific type of insulation commonly used for building wire, especially in dry and damp locations. It has a higher temperature rating compared to TW, which stands for thermoplastic water resistant. This difference in temperature rating is crucial for the safety and performance of electrical circuits. When selecting wire for a 15 amps or 20 amps branch circuit, it's essential to consider the ampacity, insulation type, and environmental conditions. For a 15 amps circuit, a minimum of #14 American wire gauge copper wire is typically required, while for a 20 amps circuit, #12 American wire gauge copper wire is the standard. However, the specific type of insulation, such as THHN, is also important. THHN insulation is designed to withstand higher temperatures, which is important in enclosed spaces where heat can build up. The National Electrical Code, or NEC, specifies the types of wiring methods and materials that are acceptable for various applications. It's important to consult the NEC and local electrical codes to ensure compliance with all applicable regulations. The NEC provides tables such as Table 310.15b16, which lists the allowable ampacities of insulated conductors rated up to and including 2000 volts in free air and in raceways or cables, based on the conductor's insulation type and temperature rating. TW cable has a lower temperature rating than THHN, typically 60 degrees Celsius, whereas THHN is rated for 90 degrees Celsius in dry locations. Using TW cable in place of THHN could potentially lead to overheating of the conductor, especially if the circuit is operating near its maximum capacity or in an environment with high ambient temperatures. Overheating can damage the insulation, increasing the risk of electrical shorts, fires, and other hazards. Furthermore, the NEC may not permit the use of TW cable in certain applications where THHN is required. For example, in many residential wiring installations, THHN is the standard insulation type for branch circuits. Using TW cable in these situations would be a violation of the electrical code and could result in fines or other penalties. When replacing wiring, it's always best to use the same type and gauge of wire as the original, or to upgrade to a high-rated wire if necessary. If you're unsure about the correct type of wire to use, consult with a qualified electrician. They can assess the specific requirements of the circuit and recommend the appropriate wiring method and materials. In addition to the insulation type, it's also important to consider the overall condition of the wiring. Older wiring may have deteriorated over time, especially if it has been exposed to moisture, heat, or other harsh conditions. If the wiring is damaged or deteriorated, it should be replaced with new wiring that meets current safety standards. Remember that electrical work can be dangerous, and it's always best to hire a qualified electrician to perform any electrical repairs or installations. They have the knowledge, skills, and experience to do the job safely and correctly. They can also ensure that the wiring complies with all applicable electrical codes and regulations. In summary, TW cable is not an appropriate substitute for THHN cable in residential branch circuits. THHN has a higher temperature rating and is the standard insulation type for many residential wiring installations. Using TW cable in place of THHN could potentially lead to overheating, damage to the insulation, and violations of the electrical code. Always consult with a qualified electrician to ensure that the correct type of wiring is used for any electrical repairs or installations. The ampacity of a conductor is the maximum current in amps that it can carry continuously under specified conditions of use without exceeding its temperature rating. The allowable ampacity of a conductor is determined by several factors, including the conductor's size, insulation type, and the ambient temperature. The NEC provides tables that list the allowable ampacities of conductors based on these factors. For example, Table 310.15b16 lists the allowable ampacities of insulated conductors rated up to and including 2000 volts in free air and in raceways or cables. The table is based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher than 30 degrees Celsius, the allowable ampacity must be derivated using the correction factors provided in the table. The ampacity of a conductor is also affected by the number of conductors in a raceway or cable. If there are more than 3 current-carrying conductors in a raceway or cable, the allowable ampacity must be derivated to account for the increased heat generated by the conductors. The derivating factors are provided in Table 310.15 . It is important to select conductors with an ampacity that is sufficient for the load that they will be carrying. If the conductors are undersized, they can overheat and cause a fire. The NEC requires that conductors be protected by overcurrent devices such as circuit breakers or fuses that are sized to protect the conductors from overloads and short circuits. The overcurrent device should be sized no larger than the ampacity of the conductor that it is protecting. For example, a #14 American wire gauge copper conductor with THHN insulation has an ampacity of 15 amps. It should be protected by a 15 amp circuit breaker or fuse. A #12 American wire gauge copper conductor with THHN insulation has an ampacity of 20 amps. It should be protected by a 20 amp circuit breaker or fuse. It is important to note that the ampacity of a conductor can be affected by the type of termination used. Some terminations are rated for lower temperatures than the conductor itself. In these cases, the conductor must be derated to match the temperature rating of the termination. For example, if a #12 American wire gauge copper conductor with THHN insulation is terminated at a device that is rated for 75 degrees Celsius, the conductor must be derated to 20 amps, even though its ampacity is 30 amps at 90 degrees Celsius. It is important to consult the manufacturer's instructions for the termination to determine its temperature rating. The NEC also requires that conductors be installed in a manner that protects them from physical damage. Conductors should be run in raceways or cables, or they should be protected by guards or covers. Conductors should not be run through walls or floors without being protected by a raceway or cable. Conductors should not be exposed to moisture or corrosive substances. It is important to follow all applicable electrical codes and regulations when installing electrical wiring. Electrical work can be dangerous, and it is always best to hire a qualified electrician to perform any electrical repairs or installations. The qualified electrician will be up to date with local codes. The NEC is updated every 3 years. Firstly, using the correct type of wire is essential for safety. Secondly, different types of insulation have different temperature ratings. Thirdly, exceeding the temperature rating can lead to overheating. Fourthly, overheating can cause fires. Fifthly, always consult the NEC and local codes. Sixthly, when replacing wiring, use the same type or upgrade. Seventhly, if unsure, consult a qualified electrician. Eighthly, electrical work can be dangerous, hire a professional. Ninthly, ensure compliance with all regulations. Tenthly, consider the overall condition of the wiring. Finally, use overcurrent devices to protect conductors.